Okay, for algebra, note 21 it says model direct variation. Make sure you put your name, date, and class period. Your essential question is, how do you write and graph direct variation equations? Alright, to write is to solve for y, and to graph it is to plug in points for domain and find the range, like we've done the past couple days. Alright, direct variation is the relationship between two variables of x and y, and usually the equation looks very simple, of y equals a number x, and they just put an a there for any number, not 0. And a constant of variation is the a. They call that the constant of variations. It's a coefficients. Alright, so for our first equation, they want us to tell whether the equation represents a direct variation. Realize here the direct variation is just a y equals, they have ax, there's nothing out here on the end, nothing there for a direct variation. So I want to solve both of these equations to see if they actually are actually classified as a direct variation. So on the first one, I'm going to draw my line here. What needs to move? If I'm trying to get y by itself, something's got to move. Well, I'm first going to take the x. This is a positive x, so to move it means it's going to change to a negative 4x. What drops down is a 2y is equal to, and then I have a negative 4x plus 0. Okay? Y is not by itself yet, so now next I need to divide everything by 2. So I have y equals negative 4 divided by 2 is actually negative 2x, and then 0 divided by 2 is just 0. So if you want, put a plus 0 there, or we can just write this as y equals negative 2x. Okay? If I go to the second problem, there's the equal, so draw your line. What's got to move? Okay, on this one, the negative 2x moves to the other side. Here it's negative, so it's going to change to a positive. Okay, that gives me y equals, and that will be 2x plus 3, and then I don't have to divide by anything, it's just a y, so that will be my equation, y equals 2x plus 3. Now, the question on these two things is, tell whether the equation represents a direct variation. And if it is, it wants us to identify the constant of variation. So, if I'm looking at the two, I have two examples. One is and one is not. Which one is it? Well, up here, we said that our direct variation equation was y equals ax. Well, that's like, for example, that would be like y equals 3x, or y equals 1/2 x, or y equals negative 10x. Now, you can have tons of examples because the a can be any number other than 0. Cannot be 0. But realize there's nothing on the end. It's just an x. There's not another number like a plus 10 or a minus 15 or something else. There's nothing on the end. So a direct variation just has the x and the y. Nothing else. There's not a constant. Well, if I look at the two, they both have x's. We're good. They both have a y. We're good. This one is a negative 2 and this one's a positive 2. Did that matter? Up here. Did it matter whether the a was positive or negative? No, didn't matter. And then this one has nothing on the end, or has a plus 0. Nothing. And this one has a 3. Well, for this case, we cannot deal with the nothing, because nothing is nothing. 0 is nothing. So if I'm looking at the two, this one does not have a constant, and this one does. Has an extra number on the end. Which one is the direct variation? Well, the correct one is this first one. This one is a direct variation. This one is not. The reason this one is not is because of the 3. That's what's making it not a direct variation. So the one that is a direct variation, it wants us to identify the constant of variation. So what's the A? For this equation, my A, I ran out of room. I'll put it over here. My A, remember the A on this is with the X. It's with the X. So my A is -2. Alright, on example 2, not foo, but 2, it says we want to graph these equations. So this first one is not written nicely. Not written nicely at all. So I'm going to put it underneath here. 3y equals 4x. And I want to solve it for y. Well, the only thing I gotta have to do is divide by 3. And I have y equals, and here's this strange fraction, 4 over 3x. Well, my A is this 4 over 3 that is with my x. Okay? But this is also my rise over my run of my graph. So for this equation, realize if it has this x here, that means it's like a +0. There's nothing there on the end. So I'm going to start these graphs at 0, 0. And then from here, I'm going to use my slope, or my A constant here, same thing as slope. And it tells me I'm going to go up 4 from here. 1, 2, 3, 4. And then I'm going to run 3. So that'd be 1, 2, 3. I'm going to put a dot right there. So up 4 and over 3. And I'm going to draw my line. These are continuous, so make sure you have arrows on the ends. If I go to the second example, it has y equals 9x. The constant of variation is 9, but I need that to be a fraction, so I'm going to put it over 1 so I know my rise and my run. I'm starting out at 0, the origin, and I want to move up 9. Okay, these are counting by 3, so 3, 6, 9, and then I want to go to the right 1, which that's difficult. Real close to that edge. Real close. This is a really steep line. Very steep line. Okay, there's our graphed equations. On the next page, we have example 3. It says the graph of direct variation equation is shown. Write the direct variation equation. Find the value for y when the x is actually going to be 10. So they want me actually find my equation. Well, it's going through 0, 0. So I'm looking at how this step is actually occurring. So I'm going to draw my triangle like we did with slope. It's going to the left there. So now I need to count. From here it goes up 1, 2, 3, 4, 5, and then it goes left 1, 2. Left is a -2. So my rise over my run is going to be up 5 and -2. So my equation will be y equals, I'm going to take this change 5 over 2 and make it negative and put an x with it, and there's my equation. If I do the same thing for the second one, I always start at the origin. I'm going to go up and then over to the point, and then I want to count it. This up went up 1 and then it went to the right 1, 2, 3, 4. So the rise over the run of this equation is 1 over 4. These are both positive directions, so neither one of those are negative. So my equation will be y equals, and I take I take this ratio and put an x with it. And there's my equation. Now, the second part, it says find the value when x is 10. Well, I'm going to use my calculator. Y equals, and I'm going to clear out what is there. And here I have a y and an x, so I'm just going to use y1. I'm going to type in -5 divided by 2 with an x. I'm going to go to the table. So they said, okay, when x equals 10, oh, there it is. X equals 10, my answer is negative, can't read that. Oh, there we go. When x equals 10, the answer is negative 25. Oh, negative 25. Okay. If I go to the second one, y equals, clear it out, 1 divided by 4x. Okay. So when x is 10, the y value is 2.5. So there's my two answers. Okay, on the last example, we have an equation that says given that y varies directly with x, use the specific values to write a direct variation equation that relates x and y. So my equation, remember, for the direct variation equation was y equals ax. So I need to find what my a actually is. And if I plug these values into my equation, the y says is negative 30 equals the a, which I don't know, but the x is a 5. So if I actually solve this, that means I would divide by 5, and a would actually equal negative 30 divided by 5. If you don't know that, type it in your calculator and see that negative 30 divided by 5 is negative 6. Okay, this is my constant of variation. So to write my equation now, I don't want the x and I don't want the y. I want those to stay what they were. But now I can say that a is equal to negative 6, and there's my direct variation equation. Okay, so if I do that to the second one here, let me draw my lines here. Taking the same equation, y is 102 equals, and then I have my a, and then the x is going to be 6 from my value. So that means I'm going to divide by 6, and a equals, what is 102 divided by 6? That would be 17. So my equation will be what? Y equals 17x. Okay, and last one. Y equals 64. There's my a, and then the x is equal to negative 8. So divide by negative 8. 64 divided by negative 8. That gives me negative 8. So what's my equation for this? Y equals negative 8x. Okay, this is the last of it. Make sure you answer your summary, and then I'll see you in class.